You're looking at a building that you would find in any part of the world. And for reasons I don't understand, we as a society have decided to build buildings out of stacks of cubes. Now the problem is that cubes have no structural integrity. And by that I mean that no matter how well I bolt this building to the ground, no matter how strong its columns and its beams are, this building is held up exclusively by its corners. It's only as strong as its weakest corners. Now, what an earthquake does principally is move the ground from side to side, and you can see how weak this building is. Many earthquakes also move the ground up and down, and again, this building is very weak. And all earthquakes produce torsion, twisting motion, and you can see this building is extremely weak. If any one of these corners breaks, this building is coming down. Now this is the exact same building, except all I've done is just snapped in these little triangular corner braces. Now look. 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 This building is strong. This building is going to survive any earthquake. This building costs only 15% more to build than this one. The cost of a bathroom in a building. But nobody is going to go from this building to this building unless they're convinced they're at risk. And that's where we failed society. We have not explained to people, in terms they understand, where the seismic risk is high, so people can see that there's a decision to make to preserve themselves and their families. And so 5 years ago, we founded the Global Earthquake Model, or GEM, to build the world's first ever seismic risk model and make it available to the public at large. Because much of this risk information is today only available in a small number of developed countries, and often only for paying customers of that information. And this is something we owe the public. Now let me show you something else. What's very common in most parts of the world is to recover the investment of building the building. The builder will use that bottom floor for retail space. Think big picture windows. No reinforcement. And now we have what engineers called a soft first-story building. This building is weak at the knees. This is the worst possible building you can build. And this building is almost certain to come down because it's heavier on top than on the bottom. And what will happen is that this building will break on the bottom floor, and all the top floors will fall at 32 feet per second and implode successively as they hit the ground. And that is the fate of so many buildings all over the world in large earthquakes. Now, these buildings are wooden, but for most buildings that we are in today, they're what we call reinforced concrete. So rather than external triangles, it's rebar, rods of ribbed steel that go through the concrete pillars and beams, flare out at the corners, and are wrapped with more rebar to make them strong. After the 1999 Izmit earthquake in Turkey, a magnitude 7.6 event, I was with a group interviewing survivors. And we met a young professional couple, the Erkmans. And they explained to us that when they were married, they were given a iron frame bed. And when the earthquake struck, their 5-year-old son was in another room. They were on the second story of one of these soft first-story buildings. And all of the stories above them slammed down on the top of their bed, but were held by that iron bed. They couldn't move. They were completely pinned in about this amount of room. Mr. Erkman was eventually able to break open the floorboard, and he found a PVC tube, and he broke it off, and water came out. And they were able to have water for the 60 hours it took until they were rescued. Their son died, and afterwards, we went to the side of their building, and the nearly identical next-door building was partially standing. And I could see a giant crack in one of these corners. And I wanted to be able to get my arm in that crack to feel the rebar and to feel how much there was. So I was put on a hydraulic lift, and I stuck my arm in, and I pulled out a hunk of styrofoam. The world would be a safer place if concrete were translucent. So what's happened in the 13 or 14 years since that 1999 earthquake and today? We've seen almost 1 million earthquake deaths.